Okay, let's try to conclude this nice paper with the second half. Where is my PPT? We stopped at figure 9 where we had been looking at the various analysis done. So there is a lot of figures, but just remember the main message. If you're an expert, you are going to realize that I'm being very brief and you will go and read the paper. If you're not, I hope you get the main message. The IMD relies on my computer is having some issues of sticky keyboards. IMD relies on using the core monsoon zone or Central India monsoon rainfall as an index for active break periods, and there are details as to how many days, what is the threshold of rainfall below which it's break, above which it's active, and so on. But you can clearly see that these are rainfall positive days when the rainfall is above the long-term average seasonal mean. You can do it in many ways, and there is below normal rainfall here, the mini break as we call them. This doesn't directly relate the monsoon intra-seasonal oscillations which are propagating northward into the Bay of Bengal from the tropical Indian Ocean, and then you get more low pressure systems coming over the core monsoon zone during active periods than during break periods. And then there are these whole arguments about whether active break periods actually make up the seasonal total and hence also appear like interannual variability pattern is similar to active break pattern, and so on, which is what Goswami keeps arguing about, and Krishnamurti has argued before that actually the active break periods and the total rainfall and the interannual variability seasonal rainfall are not that closely related. So this approach of using the multi-channel singular spectrum analysis allows Krishnamurti, good friend, I shouldn't be saying his name wrong, into two leading modes based on spectral analysis. He gets a 45-day band and a 29-day band and combines them and reconstructs, looks at OLR, winds and other things to confirm the dynamics behind them, and then also finds propagating modes which relates the mesos to active break periods. And he has papers already showing that the monsoon is made up of a stationary mode and propagating modes, where he mostly looks at the phases of the propagating modes and not so much active break periods. This paper is much more focused on the active break period. So in his reconstruction, this is his way of doing active period and break period. So this is his ISO AIMR, where he's looking at ISO 1 plus ISO 2 AIMR active period, ISO 1 plus ISO 2 AMR break period, and the idea is that looks very similar, but it's capturing the Western Ghats regions very well along with the core monsoon zone, and the ISO 1 plus ISO 2 also corresponds much better with the total rainfall than the IMD approach. And here in E and F we are looking at phases 2 and 3 of the ISO 1 plus ISO 2 AMR and phases 6 and 7 of the ISO 1 plus ISO 2 AIMR, all in millimeters per day. The scales are different, so you have to be careful. But we'll see a few more figures, then it'll become clearer. Now they are looking at how well they reconstruct the total rainfall from the ISO 1 plus ISO 2 approach. So these are reconstructions, RC in the previous podcast, by the way. I'm not sure if I mentioned. They're reconstructions using ISO 1 plus ISO 2. Basically, the EOF patterns have a spatial mode and a time series, and you multiply them together to get the value of the anomaly at any location associated with that EOF, and you add multiple EOFs to see how many of them you need to explain most of the variance in the total quantity of anything, in this case the rainfall. So we are looking at phase composites of the AMR index of total rainfall from IMD, which is 1901 to 2021 in blue, and reconstructed ISO 1 plus ISO 2 in green, and so this is based on the phases of AIMR index of ISO 1 plus ISO 2 reconstruction. So you can see they are closely matching each other. That's the phase. And here you are looking at the, in B we are looking at phase composites of the central India monsoon rainfall total. So the idea is that their approach captures both the total rainfall and the core monsoon zone, which is the IMD focus, and then the argument is that IMD doesn't do the total very well compared to this approach. And these are phase composites of the AIMR index of total rainfall anomaly based on the phases of AMR index in blue and CIMR index of ISO 1 plus ISO 2 reconstruction. So obviously again they are close to each other. So every which way you dice it, this is better, but then you look at few more correlations in a minute to see that active break periods in this construct does not really explain the total rainfall nor the interannual variability. So that rejects the other hypothesis proposed by Goswami. So here you are looking at UF1 ISO 1 of trim rainfall. So you want to validate your approach from the IMD rainfall with some other product like trim rainfall, which also has satellite period OLR, which is these are trim is from 1998 to 2019 and OLR is from 1979 to 2021, and the winds here the projected let's read carefully. Trim rainfall ISO 1 EF01, ISO 2 EF02. They are similar, but this is a weaker amplitude and they add up together, but you can see here they are different. Here they look like, this looks like a weaker phase of this, but here it's completely opposite. So you see the connection to the northwestern tropical Pacific as well. And of course there are ideas that the mesos are actually just propagating in from this region as Rossby waves, but there are other details as to northeastward propagating modes, northwestward propagating modes, and so on, which is not addressed here. So looking at 850 hectopascal winds of ISO 1 and ISO 2, there are some details on how these are done. This is ISO 2 of 850 hectopascal horizontal wind anomalies obtained from projecting PC1 of the RC of OLR anomalies. You reconstruct OLR using EOF, so you just choose dominant mode and look at PC1 regression onto winds, and basically you see the cyclone anticyclone patterns, which gives you the local Hadley cell sense here. This looks similar but weaker, similar to this pattern, but here they are very different. So you see cyclone here and you see an anticyclone here, right? So they are details that add up to the monsoon region with propagating signals and stationary signals. So you look at the correlations of the total and ISO 1 and ISO 2, basically the correlation is negligible. And if you look at SST, there are interesting patterns. The ENSO signal doesn't appear so much. There is North Indian signal here, which looks actually like the Central Indian Ocean mode that Lezo and others have proposed, where I am also involved. So these are point correlations of the daily AIMR index of ISO 1 reconstruction and ISO 2 reconstruction of IMD with daily anomalies of SST for the period of JJS for 1982 to 2021. So just remember, different periods are used based on the data availability. And again, so you have the North Indian signal, which is strong, but the Pacific signal is not strong in these ISO 1, ISO 2 point correlations with SST, which should tell you about their stationary mode and their propagating modes, which add up to, these ISO 1, ISO 2 add up to the active break periods, and they seem to be maybe more locally controlled than ISO, but you will see more correlations here. You look at number of active days and total AMR, not related, correlation is only 0.05. Number of break days and total rainfall, not correlated, correlation is minus 0.14. And if you look at active and break amplitudes, again correlations are basically 0. And if you look at number of active break cycles and total AIMR, again there is hardly any correlation at 0.17, which is not significant, which means their main message is that the active days and break days and the amplitudes and the number of events are all unrelated to the total rainfall. So that concept of Goswami is totally negated here. If you look at the number of, so this is point correlation of JJS seasonal anomaly of SST with a number of active days, number of break days, amplitude of active days, amplitude of break days, and number of active and break cycles of ISO 1 plus ISO 2 reconstruction. So you can now see that in the number of active days, there is a IOD-like pattern here, maybe a La Nina-like pattern, but that appears much more like a warm El Nino pattern dominating the break days. And amplitude of active days again has a La Nina-like signature with the basin mode of Indian Ocean here, and amplitude of break days has a La Nina pattern with not a very significant warming here. And if you look at number of active break cycles, then maybe it's not so important, but maybe it corresponds more to the Central Indian Ocean mode, which is done as a combined EOF of daily SSTs and 850 millibar zonal winds. So the question there being addressed in Central Indian Ocean mode is that Jiang et al. Have proposed that the vertical shear gives you the energy with some horizontal vorticity and barotropic to baroclinic coupling and so on and so forth, which I won't go into here. I've discussed it elsewhere. The Central Indian Ocean mode says it is the horizontal shear of the zonal winds that is very important for the propagating mode. So this is kind of bringing out some of those aspects, but the main point here is that this approach combines propagating mode and modes and active break cycles, which is very important. Okay, so finally looking at the frequency distribution of AIMR index of ISO 1 plus ISO 2 reconstruction, and total daily rainfall anomaly minus the seasonal anomaly for strong, weak and normal years in red, blue and green, and all monsoon years in 1901 to 2021 in the black lines. For in both these it's all years, strong years, normal years, weak years. And the main message again is that the intraannual variability is not really connected with the weak and strong active break periods or the intraannual variability of the monsoon does not look like active break cycles, which is the Goswami argument. This also kind of negates many the things I've said many times, that other investigators find that global warming, El Nino, La Nina, IOD, everything seems to project onto the intraseasonal time scale, which we typically refer to as the active break periods as well. So this complicates things, because maybe looking at anomalies of total rainfall versus this way of doing ISO 1 plus ISO reconstruction captures more subtle connections to the external forcings, as we saw here, through number of days of active break periods as well as amplitudes and number of events of active break cycles. Where does that leave us? Well, a new paradigm is indeed proposed, and this is argued to also improve the opportunity for predictions, which I will mention here as we read summary and conclusions. This study has introduced a new paradigm for characterization of the active break cycle in the Indian summer monsoon. It's a very important and intrinsic time scale, very critical for water resources, agriculture, energy, and so on, so we have to worry about it. An objective definition of the active break periods is provided in terms of the phases of two leading ISOs of the monsoon. When you say phases, it's propagating, of course, and this is how it's connecting the northward propagation modes and the westward propagating modes with the active break periods. Typically we think of mesos as propagating up into the Bay of Bengal, and they let's say deposit some energy here, and then low pressure systems move into the core monsoon zone or onto the monsoon region, and you have more low pressure systems during the active period, fewer during the break period, without directly connecting to the spatial index of the IMD and so on, whereas this approach tries to connect both, which is excellent. An objective definition of the active break periods is provided in terms of the phases of the two leading modes, leading ISOs of the monsoon. Further, it is shown that the intraseasonal oscillations that define the active break cycle make negligible contribution to the seasonal mean rainfall and to its interannual variability. This has been a pet peeve of Krishnamurti for a while. He has papers on these before. The results and conclusions of this study are based on the analysis of 121 years of daily rainfall data over India on a high resolution 0.25 degree grid, but remember that this is a reconstruction of station data, and later periods merges other data. As you go back in time to 1901, there are fewer stations and of course no satellite data and so on, so you have to be careful. That's why they find further support provided by the analysis of 43 years of daily OLR and horizontal wind, trim rainfall period as well. The ISOs were extracted by applying the multi-channel singular spectrum analysis, a data adaptive method without using any presumptions and pre-filtering on daily IMD and trim rainfall, OLR and the 850 hectopascal horizontal wind. People who use MSSA will always argue that this is the best, most objective way of doing things without filtering. I think Gill was the first one to propose this, and he's of course a very convincing guy if you believe in his arguments. The two leading ISOs with broadband periods centered at approximately 45 and 28 days are initiated in the equatorial Indian Ocean and propagate northeastward. So here again I should mention they only talk about northeastward propagation, whereas the general filtering approach has led to something like a northwestward. So the quasi-biweekly things propagate northwestward and the slower frequencies move northeastward. The second ISO, this is the two leading ISOs. The first one, slower one, is propagating northeastward. The second ISO includes a westward moving component over the West Pacific. The two ISOs bring excessive rainfall over central India and western Ghats for several days during certain phases and efficient rainfall during the opposite phases. So here the 28-day period is the lower frequency is moving westward, not northwestward as talked about by other papers. So it's slight difference. We looked at the western tropical Pacific signature in correlations and winds. The two ISOs together capture the daily variability of the total rainfall anomaly at intraseasonal time scale during the monsoon season. The low-level horizontal winds strengthen the climatological mean monsoon winds during the above normal rainfall phase and weaken the mean winds during the below normal phase. So the cyclone anticyclones actually add to the southwesterlies or subtract from them at intraseasonal time scale. Based on these results, this study introduced an objective definition of the active period as the period when the phase of the two combined ISOs is in the interval of pi over 4 to 3 pi over 4, and break period to occur during the phase interval 5 pi over 4 to 7 pi over 4. Imagine a circle of 360 and where you are. The AMR and CIMR indices of the total rainfall anomalies as well as the ISOs follow the same active break cycle. So in this case they are saying the IMD definition is completely reconciled with their approach, except their approach captures the AMR active break as opposed to just the core monsoon zone, which is of course very useful for predictions, especially considering there are out of phase relationships between the central Indian region and the northeast monsoon region. Okay, so finally the results of this study bode well for future advances in the prediction of seasonal mean rainfall, because coupled ocean land atmosphere models are getting much better in simulating large-scale boundary conditions of SST, which is the dominant forcing for seasonal mean rainfall. If the seasonal mean rainfall were determined by the intra-seasonal fluctuations, the predictability of the seasonal mean rainfall would be dictated by the predictability of the intra-seasonal variations, which we know is limited. Okay, that's a kind of a detail that's important, but this is how you can think of it. The coupled prediction models are doing the monsoon. Then you can diagnose them into northward propagating mode, stationary mode in these people's work versus active periods and break periods as IMD does. And then when you do predictions, you are using either a coupled model or a model that is forced with SSTs from the coupled model to go back to short and medium range, let's say 1 to 3 days and 3 to 10 days, and weeks 2 to 4, or that goes into active break periods. So if active break periods are indeed better defined this way and cover AIMR as opposed to just CIMR, then this is a better approach and is a better way to focus on predictions. And then you have to see how ISO 1, ISO 2 and their reconstruction together help the prediction, because when you do predictions, again you are using an index to translate that into rainfall using the phases and so on. It's an engineering approach, a multi-tiered approach, but it doesn't matter, because as long as you produce skillful, useful, usable information for the sectors we mentioned, like agriculture, water, health, energy, etc., it's all okay. But understanding the physics this way is also very important, and can expect that there will be responses to this paper saying no, break periods, active periods do add up to seasonal totals, and they do help explain intra-annual variability and so on and so forth. So this is how science proceeds, and it's a very useful way to think of these things as well. Okay, I hope the main points are clear. As I said, I'm brief, even though there are 2 podcasts. The details are tremendous in terms of all the statistical analysis, which I've kept very brief here, so you can go back and read if you are interested in more details. The next topic is going to be about agriculture. I've collected a series of articles focused on India, so I will include a podcast on those if I read them and find that they are really worth reporting. Okay, either way, see you in the next podcast then.